NASA announces new technology. NASA announces successful test of new propulsion technology for treks to deep space. The rotating detonation rocket engine is powered by supersonic technology, in a breakthrough that could revolutionize the way humans travel in space. Welcome to Campus Faction. If you enjoy this type of content, then subscribe and hit the bell icon so you never miss out on any of our latest and greatest uploads. As NASA gears up for a return to the moon with the Artemis missions, the administration has announced that its researchers have successfully developed and tested a new type of supersonic rocket engine, called a rotating detonation rocket engine. The rotating detonation rocket engine, or RDRE, generates thrust with detonation, in which a supersonic exothermic front accelerates to produce thrust, much the same way a shock wave travels through the atmosphere after something like TNT explodes. NASA says that this design uses less fuel and provides more thrust than current propulsion systems, and that the RDRE could be used to power human landers as well as crewed missions to the Moon, Mars, and deep space. NASA's test of the RDRE featured 3D printed parts made with a copper alloy called 𝐥𝐢𝐤𝐞, which the agency developed. During the test, the rocket withstood the high temperatures and pressures generated by the detonation, producing over 4,000 pounds or 1,814 kilograms of thrust for almost a minute. NASA argues that the new rocket design can move more mass into deep space with less fuel, potentially making space travel more sustainable. With the successful tests, NASA engineers are now working on a fully reusable 10,000-pound or 4,536 kilogram RDRE to compare its performance to traditional liquid rocket engines. NASA's development of the RDRE signals the Space Administration's interest in developing more efficient rocket technology for space travel. Earlier this week, NASA announced a joint collaboration with DARPA to develop 𝐦𝐨𝐬, short for Demonstration Rocket for Agile Cislunar Operation. 𝐦𝐨𝐬 would utilize a nuclear thermal engine for interplanetary travel, reducing travel time with a more efficient propulsion technology. NASA continues test series for redesigned Artemis moon rocket engines. NASA's testing for redesigned RS-25 engines to be used on future Space Launch Systems SLS missions continued with a March 8 full-duration hot fire at NASA's Stennis Space Center near Bay St. Louis, Mississippi. The test, conducted on the Fred Haise test stand at NASA Stennis, was the third of the year and part of an ongoing certification hot fire series. It also was the third test since an upgraded nozzle was installed on the RS-25 engine just prior to a February 8 hot fire. The redesigned engines, provided by lead SLS engines contractor Aerojet Rocketdyne, will be used on future Artemis flights to the moon, beginning with Artemis 5 as NASA continues its mission to explore the secrets of the universe for the benefit of all. Early indications are that the nozzle is working well, said Mike Lauer, Deputy Program Manager of RS-25 engines at Aerojet Rocketdyne. Even though we changed manufacturing methods, we did not want to radically change the performance of the nozzle. We are very pleased that the nozzle appears to be performing very much in line with our previous history. Operators fired the RS-25 engine during the test for a scheduled 520 seconds and up to 113% power level. During missions to the moon, engines fire for about 500 seconds and heat up to the 111% power level to help SLS lift the Orion spacecraft and other payloads to orbit. With added seconds and the increased power levels during ground tests, engineers can learn more about engine performance and provide a margin of operational safety. The nozzle, or bell-shaped part at the bottom of the RS-25 engine, helps generate thrust by ejecting the engine's exhaust at maximum speed to propel SLS to space. It is one of multiple upgraded components on the redesigned engine and also critical in ensuring efficiency by using a minimum amount of propellants or fuel to generate thrust and help propel the rocket to space. The nozzle is one reason the RS-25 is one of the most fuel-efficient rocket engines in the world. Over the course of the storied history of the RS-25 engine, many components have gone through changes or upgrades. One component that mostly went unchanged was the nozzle. For redesigned RS-25 engines, however, a team focused on re-engineering every part of the nozzle. This included using precision machining to improve production of the more than 1,000 tubes that comprise the nozzle wall. And with that, we've reached the end of this video all about new technology announced by NASA. If you enjoyed this video and found it helpful, don't forget to leave a like and subscribe for content just like it.